this way. Are we together? Which is a vibration. So we are trying to study vibration using circular motion because we know the equations relating to circular motion. Now we want to use those equations to come up with an understanding of vibration. Are we together? Right. So we have our wheel, it's pivoted there, and it's going round and round. And we have our board, and we've now placed the slot in there. So what happens? This is going round and round, this is going like this, at the same frequency. They are moving together. So they have the same frequency. Are we together?
Yes.
Right, let's see what's happening. Now, you will then notice that the extreme positions for the slot is this point and this point. And the midpoint is that. So movement from one extreme position to another, that's what we call amplitude. From this point to the end, that point to the end, that's amplitude. Are we together? Right. Let's consider the point when the wheel is, let's say, somewhere there. That will be the angle that is opened up. Okay? If we take this wheel to be moving at a speed omega, we know that if we are dealing with linear motion, S is equal to Vt. Displacement or distance moved is equal to velocity times time. In rotational motion, when we talk of displacement, we talk of angular displacement, the angle moved. And this must be equal to angular velocity times time. Okay? And if that is the case, when it is at this point, now notice, if this is x, that means actually the radius of this thing is actually x. And at this particular point, displacement from the center is this, which we call small x. Now, writing an expression using that triangle which we have formed, you notice it's a right angle triangle. It's right angled at that point, and the x side is adjacent side, so it's a cosine relationship, which means we can say x is equal to x cos omega cos theta. The angle there is what? Theta. Now we know that theta is equal to, so we can also say x is equal to x cos omega t. Because this theta is not a constant value. It's changing. This thing is moving like that. And the actual variable is time. Because it's changing with time. So we can express it that way. Are we together? This then represents the displacement x for this thing here at any time. So that's the expression for the displacement at any time t. That being the case, if that is the displacement, we can use that expression and we can find velocity. Velocity is the first derivative, dx by dt. The first derivative of x.